GRP versus REST, two ways to let one program call another program across a network, and the choice quietly decides two things: how fast your system is and how many people can actually talk to it. In this video, we go all the way down to the code. By the end, you will know exactly what travels on the wire in each one, why one of them is roughly half the size, and the one very good reason teams still pick the bigger one on purpose.
REST, because you have already used it today without noticing. An API is just one program talking to another. In REST, you point at a thing, a user, an order, an invoice, using a web address. You use a plain verb like get, and the server sends back text. Usually JSON, curly braces, field names in quotes, values sitting next to them. That is the whole idea. No setup, no shared file, no build step. Anything that can open a web page can make this call.
Here is the entire thing in code. On the server, one function. The line above it says, when somebody asks for /users/a number, run me. The function returns an ordinary dictionary, and the framework turns that into JSON text for you. On the client, one line. You give it a web address, you get text back, you pull a field out of it. Now notice what is missing. No schema, no generated code. Nothing the two sides had to agree on in advance except the shape of that address.
And that is the trade you just made. You paid for the simplicity, you just never got an invoice for it. Nobody is checking that the server still sends a field called email. You find that out when your app breaks. Every single message carries the field names again, spelled out as text. And the classic web, HTTP version 1.1, largely sends one request at a time down a connection. So a service that chats a lot spends a lot of its life standing in line.
gRPC starts from the opposite end. Before you write any code at all, you write the contract in a file called a proto file. Read it top to bottom. There is a service named users. It has one remote procedure. That phrase just means a function that runs on somebody else's machine, called getUser. You hand it a user request and you get a user back. Then the message itself, an ID, a name, an email, and a true or false flag. And look at the numbers down the right-hand side. Those numbers, not the names, are what actually travels.
Now you run that file through a compiler called protoc. Out the other side come real classes in whatever language you asked for: Python, Go, Java, C#, whatever your teams actually use. Both sides then import generated code built from the very same contract. So if somebody renames a field on Tuesday afternoon, your build breaks on Tuesday afternoon, not at 3 in the morning in production in a log that nobody is reading. That is the real product here, not speed, agreement.
Which is why the code barely looks like networking at all. On the server, you simply fill in the method the contract already promised, and you return a typed user object, not a dictionary you are hoping is shaped right. On the client, you hold something called a stub. You call getUser on it like a normal function inside your own program. There is no address to build, no JSON to parse, and no key to misspell because there are no text keys anymore. The field is an attribute, and your editor completes it for you. So here's what those two calls actually put on the wire. The REST reply is 76 characters of text. Half of it, 38 bytes, is the content you meant to send. The other half is packaging: quotes, colons, commas, and the field names spelled out again on every message, forever. That exact same user in Protobuf is 37 bytes, and only 6 of those are packaging. The names are simply gone. Both sides already have them, sitting in the proto file. The connection underneath changes too. gRPC runs on HTTP version 2, which lets many calls share a single connection and travel interleaved instead of queuing up behind each other. That unlocks 3 shapes that REST does not have on its own: one question and a stream of answers coming back, a live feed; a stream going up and one answer coming down, an upload; or both sides talking at the same time on the same open line. In REST, you would reach for polling or server-sent events or WebSockets to fake any of that. And the code cost of all that is one word. In the contract, you write the word stream in front of the return type. Now, on the server, you yield values as things happen, instead of returning once and hanging up. And on the client, the call is simply a for loop. You walk the responses as they arrive. Same stub, same connection, no new infrastructure to run. That is the moment gRPC stops being a faster REST and becomes a genuinely different tool.
Now the catch, and it is a real one, curl works against a REST endpoint right this second on any machine with nothing installed. A browser cannot speak raw gRPC at all. JavaScript inside a page is simply not given that low-level access to the connection. So you put a translating proxy in front of it, called grpc-web, and that proxy is one more thing you run, monitor, and pay for. And once your traffic is binary, your CDN cannot cache it, and you cannot read it in a log with your own eyes.
So the honest scoreboard reads like this: roughly half the bytes, types checked at build time, and streaming for free, set against a thing that every client on Earth already understands. And notice, nothing was compressed and nothing was dropped to get from 76 down to 37. The field names just stopped traveling. If you send that message once a day, this is noise. If your services send it 200,000 times a minute to each other, it is a bill.
So here is the decision rule you can actually use. If the caller is a browser, or the public, or somebody you will never meet, use REST. Reach beats efficiency every time, and having no contract means nobody has to install anything just to talk to you. If the caller is your own service, inside your own network, called constantly in more than one language, use grpc. You are paying a setup cost once to buy typed calls and small messages forever. And most real systems quietly do both. REST at the edge, where the world touches you. grpc behind it, where your own services talk to each other. If that made the difference finally click, hit like and subscribe. One concept all the way down to the code, every time. The 90-second version of this one is linked in the description. Next up, what actually happens inside HTTP version 2 when all of those streams start competing for the same connection?